Hello, my name is Jessica Dean, and I am a cloud developer advocate here at Microsoft. I focus heavily on DevOps from the ops perspective, and even more shocking, I have a deep passion for Linux and open source. Today, I'm going to show you how you can do .NET development in Azure with Visual Studio Team Services in conjunction with Linux and open source tools. Now, with my background of Linux system administration and deep engagement in local open source communities, I had to go learn VSTS. What I was surprised to discover is how easy it is to configure your build and release stages for your .NET web application in your CI/CD pipeline using VSTS. For today's demo, we are going to use a .NET Core web application and deploy it into a Linux-based Azure container instance. We are also going to do this from my Mac. Before we get started, I want to highlight a few things about Azure Container Instances, or ACI for short. Some key benefits of using ACI versus, say, Azure Container Service, or ACS, are you can get started quickly and you can scale containers on demand. What this means is there are significant startup benefits over virtual machines. With Azure Container Instances, you can start a container in Azure in seconds with one single command, without the need to provision and manage a virtual machine, as you do with Azure Container Service. That means there's no need to go out and learn new container orchestration tools. So you don't need to know how to manage a Kubernetes or Docker Swarm cluster. And with ACI, you can easily deploy images right from Docker Hub or Azure Container Registry. Let's go check it out. Okay, so I have already pre-created a project to show you in this demo. We are currently looking at my project in my VSTS collection. The name of my project is .NET ACI LX for .NET Azure Container Instance Linux. So I've already created a build definition. Let's jump in here and see how this is configured. So here we are taking a look at our build definition. We see that under tasks, it's broken up into process, get sources, and a phase. So if we take a look at process, we see the name of the process, and it's our .NET ACI LX Docker CI. We also see agent queue. Since we're building a .NET Core application that we're going to publish into Azure Container Instance, we are going to use the hosted Linux preview agent, meaning we're going to build this on a hosted Linux machine. Next, we're going to select Get Sources, and I have already imported the sources I need for this particular project into a Git repository from within VSTS. Next, I'm going to start to define tasks for the phase of my build. I can add tasks easily by clicking the plus sign right here to add a task to this phase. And I could choose a .NET Core or Linux. I can search in here for Docker if I wanted to add a Docker command. For this demo, I have already pre-configured the tasks. So let's take a look. First, I've defined an npm task to install Bower. It works exactly as you think it would. npm install, and the arguments I'm specifying is Bower and allow root. Next is I'm running a normal command line or shell command where I'm calling Bower and I'm telling Bower to install and allow root. Next, I'm going to specify the version of .NET Core I want to use for this build. I'm going to use .NET Core SDK 1.0.4. I've specified that the package to install is an SDK, not a runtime package, and the version is 1.0.4. Next few commands I'm going to do are .NET commands. So I'm going to do a .NET restore, and I'm going to specify my solution file, and I'm going to also attach some arguments of no cache. Next, I'm going to run .NET test, and I'm going to specify my csproj file so I can make sure that we check our test results. I'm also going to have it output a TRX file, and the immediate step after that is that I want it to grab those test results and publish them. Next, I'm going to run a .NET publish command. Check the box to publish web projects, and I'm also going to add in the arguments to specify my configuration file, which you'll notice is an environment variable. We'll show that in a second. And the output, which is also an environment variable, and pub for the public folder. Next, I'm going to copy my Docker file from my source, from my repository from within VSTS, to the target folder for build. This way it's not copying all the documents or all the files within my repository, it's only copying the ones I need for the release stage. So if we click the ellipses here next to source folder, we can see all the folders that are located within my repository. Underneath source, I have my Docker file right here. So I choose the source folder and I specify the file that I want to copy. I also choose the target folder of where it's going to be copied to. Next, I'm going to build an image. I've specified my container registry, and I've specified the action is building an image. I'm also telling it which Docker file to use, specifying any build context, and the image name. Now the image name I'm using is my Azure Container Registry name, as well as the project name and the build ID. I can check the box to include the latest tag if I want, and I can add additional tags here. Now let's pause real quick and talk about the Azure Container Registry. I have already pre-configured that in services. So if I click on Manage and open that up in a new tab, we can actually see the services that I've already added in. One, I've added in a Docker registry. And if I click Update Service Configuration, I can see that the Docker registry is actually my Azure Container Registry. I also see the Docker ID, and I've already entered in my password. I've also added in my Azure subscription. So if I click on this and click Update Service Configuration, we can see the connection name and the subscription. If I were resetting this up or setting it up for the first time, I would simply click New Service Endpoint and choose which endpoint I want to add. I can add a Docker registry, as I said. I can even add things like Jenkins, Kubernetes, NPM, and so on and so forth. So going back to our build task, we've already added in the data necessary to build our image. Now we're going to add in similar data for pushing our image. I've named this push an image. I'm choosing that I'm going to push it to a container registry. I've specified the Docker registry connection as being my Docker registry that I have already added in. I only have one. And then the action that I want to choose is push an image. Next, I'm taking the same image name I referenced in the build. And in here, I could also choose if I wanted to push multiple images. I can push my build ID and the latest tag simultaneously. Next, I'm going to copy my ARM template files. I'm going to copy the JSON files I'm going to use for my deployment in my release stage. We'll take a look at the release stage in a second. But you'll see under my repository and under my templates folder, I have all of my templates that I'm going to use for this deployment. I'm just going to copy that over into my staging folder under my staging directory, pub, and templates. Finally, I'm going to publish that so that I can use it in my release. So let's go ahead and hit Q so that we fire off a build. It has now fired off a build for our .NET Core application that we are going to publish into Azure. So we see here it's actually going to initialize our hosted Linux agent, and it's preparing the build. It's already downloaded the tasks, it's gotten our sources files, and now it's installing Bower. So I can see that it ran the command npm install Bower allow root. Next, we are running Bower, where we're running Bower install allow root. And now we're telling it to use .NET Core SDK 1.0.4, and it's already moving on to our .NET restore command. Now it's moving on to .NET test, and it's publishing those test results. Now we've moved on to .NET publish, and we're already in the build phase for our Docker image. It's now pushing that image to our Azure Container Registry. It's copying the ARM templates we're going to use for deployment, and it's completed our build. Great. So now that means it's already set it up to go to release. Let's take a look. We see release 4, it has started. While it goes off and does the deployment, let's take a look and see what it's doing. There aren't as many tasks for the release stage. So first off, in my pipeline, I've defined that the artifacts it's going to use for the release are to come from my continuous integration build. So if I click this, I can actually see the project, the build definition that it's going to pull from, and it's going to grab the latest version. Can always choose to add an artifact and set up any continuous deployment triggers. Next, I can create environments. For the demo, I've created a single dev environment, and I've told it to automatically trigger after release, and there aren't any pre-deployment approvers needed. Though if I wanted to, I could configure those here. Next, let's go ahead and click on the phase and task. You'll see that I only have one phase and one task. You'll also see that this deployment is actually happening on a Windows-hosted server. And all we're doing is doing an Azure Resource Group deployment command. So I've added in that task already. I've named it accordingly. I have specified my Azure subscription connection, that I'm going to use Azure Resource Manager, and my subscription is selected here. Next, I chose to create or update a resource group, so it's going to create my resource group for me with a variable that I've specified. I'll show you the variables in a second. And then we've also specified the location as West US. I've referenced that template file I showed you that I copied from my templates directory in my build definition. I've also specified a parameters file, again in that same templates folder. I've also used additional template parameters where I'm specifying, again, still variables with the container name, the container URI. This is where I'm referencing that image that I built and pushed to Azure Container Registry as part of my build definition. Next, I've also specified the image registry login server information, which includes the container registry, the registry username, and the registry password. So let's take a look at those variables. You'll see the container registry password. I've actually encrypted that so that's not visible in plain text. And then the container registry username. You can also specify the image port, which I'm using, and then the resource group name, which I referenced earlier in my release stage. If I wanted to add a new variable, I would simply hit add, name it, type in the value here. If it needs to be encrypted, I would hit the lock, and then I would hit save. We don't need any other variables, and we do already have a release running. Let's go check it out. So I can see the release is running. If I double click on it, I can actually see general information and details about the release. I can also hit logs to watch as it releases. So I see that it actually just completed, but I can see that it ran on the agent. It initialized the job, it initialized their agent. It downloaded the artifacts, meaning it downloaded the files that we need to use for this deployment. You'll notice it downloaded the JSON files that I had copied from that templates directory. Finally, it executed the task that we defined, where it executed the deployment script, referencing the JSON files that I need, and I selected an Azure subscription. So it can confirm that it created the resource group accordingly. It created the resource group deployment, and it completed successfully. So if we go over to the Azure subscription and refresh, we now see that resource group that it created. We see our Azure container instance listed in here. It's just a container group. It's a single instance. And I also see an IP address. So let me copy that. We should be able to paste that in and see our .NET Core web application. And there we go. We have the .NET ACI LX web application that I created. So there you go. .NET Core development in Azure using VSTS. We were able to seamlessly tie in Linux with our build agent, open source tools such as Bower and .NET Core during our build. And then we even used a hosted Visual Studio 2017 Windows agent queue for a release into Azure on a Linux Azure container instance. This really shows how VSTS can completely handle your .NET development in Azure with standard DevOps practices, and what's even more cool is how you can do it from any platform. Thank you very much.